recording here. So what we've seen is, three parts of Catlab in quick succession. We've seen a category, although I didn't really call it out till late in the game, associated with finite sets and functions between those finite sets. And we saw that we could have identity functions. So each set has an identity function to it. And we saw two end-to-end functions could be composed. And I noted that if we had a function f and we composed it with the identity function or identity function with function f, we'd get back function f. And although I didn't show it, I noted that it was associative. If we have function f and g, and then we compose it with function h, it's the same as taking f and then composing it with g and composed with h. And it's the same in the sense we don't have to worry where the parentheses are between them. We just say f after f followed by g followed by h. We don't have to worry about putting parentheses there. So it has associativity. And then we saw similarly for relations. We saw that we have sets of finite size. We have in FinRel, we have the morphisms like in with the category FinSet, they go from a given object, a set of a finite set, to another set. But unlike functions, they encode relations between those sets, so which we could characterize as tables even. Although we also saw we could characterize them logically by the rules by which an element of first set and the element of the second set were related. But we saw also, or at least I asserted to you, that we had identity relations on these finite sets, and given two relations from set A to set B, finite set A to finite set B, and finite set B to finite set C, I could compose them, and it was quite different in its particulars, in its mechanics. But that led to a relation from finite set A to finite set B, which honored unitality. So composed any relation with identity gets back to identity in either order, identity first or identity second, and composing relation R with relation S and with relation T, it doesn't matter where the parentheses are. R and then S and the T is the same as R and S and then T. And so I said they're categories, and then I went in and I showed how you could define categories, and more specifically define. We can specify presentations of those categories, finitely present those categories, and we looked at something that was freely presented. So any two morphisms end to end automatically have a morphism that, absent some specification from us or something stipulated by the rule, the axioms of categories, is a new morphism. We could finally present these categories, and we do so by specifying generators in the form of objects and morphisms, and then in the form of relations, which specify kind of rules that indicate, for example, when we compose reflexive edge morphism with source, we get back to identity on the vertex. That certain compositions are equal to ones that have already been specified among the generators. So we can have these relations, these equations specified, and the categories remember this structure. And we can compose morphisms in the categories. We can compose them with identity. They know about relations, but they, at this point, fall short of enforcing relations. Okay, so those are all my comments here for now. I'm going to turn it over to Xiaoyan for really introducing the most exciting stuff, which is really taking some of these categories as schemas, and mapping them over to FinSet and creating instances of them, which are these really powerful gadgets that have all these wonderful categorical properties that we'll be able to explore with them. So with that, I'm going to